Well, hi everybody. Good afternoon, evening, morning, I guess depending on where you are in the world. I'm Jeff. I'll be your instructor here for today. So just to make sure that you guys are hearing me okay, could just jot in the chat window or say if you can see me and hear me just fine. Otherwise, I'll make sure I fix whatever might be going on. Awesome, thumbs up. A few people already know how to use the buttons here, so that's good too. All right, great. So again, my name is Jeff Rensink. I am the full-time wireless instructor over at IP Expert here, which basically means if it's wireless, I'm the one in charge of it, all the way from the NA up to the IE. So if you're somewhat new to IP Expert and you're wireless, you're probably going to be getting familiar with me over the course of time here. So today we're going to be doing what's referred to as a V lecture, just kind of a short class on a focused topic. And the topic we'll be discussing today is the CAPWAP AP discovery or controller discovery process in the Cisco Lightweight world. Before we dig into that, just a couple words about the classroom interface if you haven't used it before. So you'll notice we do have a chat window. That's usually the best way to interact with me in a class like this. I will just make a note there. When you do type in and hit enter, I don't really hear an audible tone or anything. So if I'm kind of talking and I'm not paying attention to the chat window because I'm engrossed in whatever I'm explaining, and you need to get my attention, try using the buttons right below the chat window. So we have a hands up button, and usually that's, I have a question, or if you need to get my attention, that's a good way to do it. We have thumbs up, thumbs down, so if I ask a yes or no question or whatever it's going to be, it's a real quick way for you to answer affirmative or negative. If I say something funny on the off chance, there's a little smiley face button, sends a little laugh track out there, and finally a little hand clap at the done. I'll stand up and take a bow, and you can clap for me. So, and then the last thing will be, as we get into some of the stuff, if I'm getting into the CLI or the GUI and you're having a little bit hard time reading it, maybe it's a little bit too small, one way that you can get a little bit better view is on the top you should have a full screen button. If you click on that, you will lose, I believe, the chat window and the buttons, but me and the rest of the content will be bigger. So if you're having trouble reading, try that. That might help. And then the last note, some people have had problems when using Chrome as their browser of choice. So if you're on Chrome and all of a sudden you start running into issues where you lose the video or it gets super bad, always feel free to ask, because every once in a while it's my fault. But you may want to try switching to a different browser or maybe just closing it, reopening it. Sometimes that helps. So with that out of the way, let's kind of go over the high-level topics of what we're going to be doing in the class today. All right, so lecture objectives. We're focusing here on the CAPWAP discovery process, so we'll do just a high-level overview of how the discovery process works. And then we'll discuss the 5 main ways that we have for discovering wireless LAN controllers when an access point either boots up for the first time or initiates a reboot. Within that, though, we'll talk about how each method works, how you configure it, both on iOS as well as in a Windows 2003 server, wherever it's appropriate. And then finally, how do we verify that it's actually working correctly? So, if it's doesn't seem to be joining up to my controllers or even attempting to, we can make sure, is it discovering it? And if not, maybe how we can figure out what might be going wrong with that. So without further ado, let's talk about just the overview of the discovery process here. So the discovery process is going to begin after an access point boots up and gets an IP address. So IP address is one of the first things that you need. Typically we use DHCP on our access points, but it could be statically IP'd as well. But once it actually gets that IP address, any idea on when the session will be, not sure what that last word, this session will be recorded. It's being recorded right now, and we'll be getting it up, I think both on our site as well as on our YouTube channel pretty quickly, so I would expect within a couple days you should probably see that in both locations. All right, so our AP boots up, gets an IP address either because it was statically configured or through DHCP, and then it's going to begin this discovery process. Now the purpose of the discovery process is to build a big old list of wireless LAN controllers to possibly join up to. Now it goes through every single method first before it even does the join attempts. So one thing some people get bogged down into is, what's the order of operations? Which one does it do first? And does it matter? Well, it doesn't really matter which order of operations it does, whether it's first, second, third. It's all just happening in this discovery phase where it's just building a list of wireless LAN controllers. So don't worry about what happens first, second, third, because it honestly doesn't matter. It's just going to build a big list, and then finally once it has this list, it'll start kind of the join process. So how to build this list? We have 5 main ways that we're going to talk about for that. There is a 6th method that is no longer around, which was over-the-air access point provisioning, but we're basically focusing on recent code train 7.0 and all the way up to today with 7.5. So, excuse me, the 5 different ways we have of AP discovery. Let me get my notes here. Or sorry, controller discovery, WLC discovery methods. Method 1 is going to be with just a layer 3 broadcast. Layer 3. So once the AP has this IP address, it just sends out a broadcast packet to an all 255's address, UDP 5246. So if there's any other controllers in its local subnet, it will be able to discover it that way. Second method, and then we'll dig deep into more of the details as we get into each one, but just really high level on each of them so far. So we have our layer 3 broadcast. We have a DNS resolution. So if the access point is able to use a DNS server, it will try to resolve a specific DNS name, and that's one way for it to discover a wireless LAN controller. Number 3, we have through DHCP, DHCP options, I should say. And the 2 options that come into play is 43 and 60. So if the access point uses DHCP to get its IP address, the DHCP server can send, in addition to the IP address that the AP will use, additional information that includes IP addresses of the wireless LAN controllers that it could potentially join up to. Number 4 is we can hard code primary, secondary, tertiary controllers. So we can just configure directly on the access point itself up to 3 controllers, a primary, a secondary, tertiary controllers that it will always remember across all reboots. So far the first 3 methods have been dynamic discovery methods, so it doesn't know it to begin with, but it learns it. Number 4 would be more of a static config. You put the config on the AP itself and it remembers it forever until you clear it out. And then the last one is previously remembered controllers, or previously known. This one comes into play if the access point was previously joined to a wireless LAN controller and then it just reboots. It will remember the controller was on as well as any mobility group members of that controller. So the last method there is one that only occurs after it's already been joined up to a controller. Everything up to until 1 through 4 can be done before it's ever joined up to a controller, so a brand new fresh AP out of the box. So these are the 5 methods that we have to discover. Again, the 6th one that used to be around was called OTAP, or over-the-air access point provisioning. No longer around in any current code, so it's not something you would ever need to worry about today. All right, so let's start digging into each of these 5 methods. How to configure it, how to verify it. So number 1 is, oops, sorry, another note here. Okay, James got it. So layer 3 discovery, or layer 3 broadcast. Now this is the only one that'll honestly work, just a brand new AP out of the box. It just does this automatically. So it's going to be a UDP packet to all 255 address. So it's a layer 3 broadcast as opposed to a layer 2, which would just be a MAC address based broadcast address. and it's going to be on port 5246, which is our CAP/WAP control plane packets. 5246 is the control plane, 5247 is the data plane for client traffic. So it sends out this UDP broadcast, and it's going to be automatic. Any controllers currently on the same subnet will receive that broadcast, and then they will respond. So that's one way to do it. The other way to do it is, let's say we want to use this method, but we want to have it discover wireless LAN controllers not on the same subnet as the access point. Well, normally we'd be out of luck because broadcasts aren't routed, but the fact that it is a UDP broadcast, we can actually take advantage of a feature in the switch configs or router configs as well. It's the IP helper command. You might be familiar with that command for DHCP. You know, if I receive a DHCP request, I can use an IP helper command to send that DHCP request off to my DHCP server. Well, DHCP request is very similar. It's a UDP broadcast, just a different port. So what we do is we just configure the switch to say, okay, if I receive a UDP broadcast on port 5246, then I can use an IP helper command to forward that off to one or multiple wireless LAN controllers. So if it's same subnet, oh, sorry. No work needed, it's automatic. Different subnet. We're going to need two commands. The first command is going to be to enable the forwarding of UDP 5246 traffic, and that is with the IP forward protocol command. Call. And then secondly, we put in IP helper statements. This is going to be solely configurable in iOS. There's nothing we can do on Windows side. So I'll show you how to configure this and make it work. All right. So in my network, I have a rack up on proctorlabs.com going on. So on Cat4 here, I have two access points in VLAN 121, and then I have a controller at IP address 10.10.120.140. So they are in different subnets right now. So at the moment, LAP4 and LAP5, they don't even have IPs yet. I don't have a DHCP scope, but they will be on different subnets, so we'll need to use that IP helper trick. So first, let's go ahead and get just plain DHCP working so these APs can at least pull an IP address. I'll configure it on the switch here real quick. So configuring a DHCP scope, pretty simple. Good trick to, or a good skill set, I guess, to know. IP DHCP pool, and I normally just name it after the VLAN that I'm serving. In this case, it's VLAN 121. We say what network the DHCP pool is for. In this case, 10.10.121.192, and it's a /26 in this case, so 255.255.255.192. And we're going to need a default gateway so that they can talk off subnet. 10.10.121.193. So now at this point, my AP should be able to at least pull an IP address and begin that discovery process. Once they have an IP, then they'll start doing that layer 3 broadcast. So hopefully very shortly, okay, we see one AP has pulled an IP address already. The other one should pull it shortly. Okay, great, they have IPs, now they can begin the discovery process. So they're going to be doing the layer 3 broadcast, but since it's on, the controller's on a different subnet, it's still not going to be discovering a controller yet. So before I actually turn that on, in terms of trying to verify this, this is the toughest one to verify because there's no good way to do it outside of using a debug on the wireless LAN controller. So just to show you what that would be, the debug would be configure. First thing, I'm going to make sure I have logging working to my console port. Logging console, debugging. Okay, so the debug, you'd get into the CLI of your controller. Right now I'm on the console port itself. And it's going to be, debug, CapWAP, and we're just going to look for packets, enable. Now the trick here, if you turn this on, if you have wireless APs currently associated to your controller, you're going to get spammed with CapWAP packets because APs are always sending CapWAP packets to the controller. So I would only do this on a controller that doesn't have any APs. So I'm just doing this for demonstration. Most of the time you don't really have to worry about validating this. It's usually, once you configure it, it's pretty automatic as long as you configure it correctly and have layer 3 connectivity between the switch and the controller. But I'll turn it on just so I can at least show you this. And yep, giving me a little warning, there's probably going to be a lot of logs, and there will be if we had a lot of APs for sure. All right, so I have APs with IP addresses. Now I need to get those layer 3 broadcasts over to wireless LAN controller 4. So I go to the switch that they're connected to, and we do the 2 commands, IP forward protocol, it's a UDP packet, and then the port. See a lot of pre-CAN ports we could choose, but we have to just type it in, so 5246. Now anytime the switch receives a UDP 5246 broadcast, it will forward it on anytime we have an IP helper command configured. So let's go ahead and configure that. I go to the VLAN interface where my access points are connected to, so they're currently on VLAN 121. And then IP helper address and the management IP address of the controller. So important to remember, I should have said this before, but we always discover the management IP address of our controllers. So that's what we want to be advertising to our access points. So the management IP address of this is 120.140. And once we get this going, I should start seeing packets show up on wireless LAN controller 4. So we just need to kind of play a slight waiting game because it's not spamming it all the time. It's just going through discovery process, and at the appropriate point in the discovery process, that's when the layer 3 broadcasts happen. So we just kind of need to wait for the AP to cycle through here. And that's assuming I configured everything correctly. I should be set to enable console debugging and CapWAP packet. All right, looks like we have a raised hand. Will debug on a controller really affect CPU utilization that much? I don't think I've seen it really bring stuff down, but it can make your console session fairly hard to use. I normally try to avoid debugs unless absolutely necessary. All right, so looks like we're still working our way through that there. Haven't found anything. Make sure I have everything right. So it's on the VLAN 121, 10.10.120.140, 5246. If you're not seeing anything, one thing you can do to just make sure that your switch has connectivity to the wireless LAN controller just from the switch where you configured your IP helper address, just can you ping the controller? Ping 10.10.120.140. Yep, so it should be able to forward those packets on. Maybe I just need to be more patient here, but usually it doesn't take very long. Okay, so now it's just joined, and I must have done the wrong command. Sorry. Same output for the IP testing. Oh, yes, to limit it. Yep. So you can use the limiters to specify, okay, where, what do I want to show for the debugs? I must have, either I missed my logging or, yeah, I am in the console, logging mode debugging. Well, I must have put the wrong thing in. So normally what would happen is I just start getting spammed with these CapWAP debugging, these debugging outputs. Let's turn it back off. Try to turn it back on one more time. CapWAP, packet, Sure you want to continue? Yes. How about CapWap? Well, that should have been it. Check out my logging levels. Yeah, I'm on the console. Interesting. All right, well, something I do honestly very, very rarely. But normally most of the time, I'm never going to do that on a controller just because I don't want to have to sift through all that stuff and do special things. Usually all I'm making sure is on my switch I have the IP forward protocol with UDP 5246, IP helper statement on my SVI, and then if I really want to troubleshoot, just ping the controller's address from the switch. As long as we have that, should work. And it did. We can see that my APs have joined up to 10.10.120.140. So I'll have to look into, I guess, specifically why I didn't get the actual debugging output. So, sorry, just looking at some of your message here. Yeah, I just had these controllers wiped, so I shouldn't be filtering out anything. I do have, I'm on the console, set to debugging. So, apologize for that, but fortunately every other join attempt that we're going to do, we don't even need to touch debugs because we can do it very easily on the access points themselves. So, apologize for that. A few words on the layer 3 broadcast method. It's usually more of a quick and dirty way to get this AP up and joined to your controller. You typically don't want to leave it in this state permanently because when we do the IP helper command, these UDP broadcasts are not the only packets being forwarded on to the wireless LAN controller via the IP helper command. All your DHCP broadcasts are being forwarded, so now all of a sudden my controller is getting every single DHCP request attempt on the VLAN where the IP helper statement was on. There's also a handful of other, I think there's maybe 5 or 6 total services that are being forwarded on with this IP forward protocol command by default. So normally you would just configure this, get the AP joined up, and then configure, maybe a static primary, secondary, tertiary, or some other way for it to join up to the controller in the future. And then when you're done, you take the IP forward protocol off, or at least the IP helper statement off. Generally, you wouldn't want to leave this up and running in a production environment permanently, especially if there's any amount of traffic happening on those the VLANs where the APs are on. All right. So that's the layer 3 broadcast. Very basic on that one, but this is how you can make it work off subnet. Let's talk about the next one. DNS resolution. Okay, so with DNS, what we're trying to resolve in any current code, I think it started off in somewhere in the 5 or 6.0 code, but definitely in any code in the last 2-3 years, is trying to resolve Cisco-CapWap-controller .domain. So whatever the local domain is, it appends that to the end. Older code would try to resolve Cisco-LWAP-controller .domain. So technically it could be either one of these, depending on code. Just about everything, though, today, unless you're running maybe some old 4.x code on something that just can't update for whatever reason it's going to be, it'll be the Cisco CapWap controller. But just to play it safe, you may want to just put in DNS entries for both. That way you're always good no matter if it's running new code, old code, whatever it's going to be, it'll work just fine. So some requirements to get DNS working. One, you need a DNS server. Something needs to actually receive the DNS request and then spit back out an IP address to resolve the host name to. We'll show you examples of using both iOS as well as Windows to do this. And then the AP itself needs a method, it needs to know of a DNS server to use. So you need to tell the access point Okay, here's a DNS server, and ideally you also tell it a domain name to use. So when it does the resolution, it appends the appropriate domain name, and then the DNS server should be able to respond appropriately. Now technically, there's another way to get the access points DNS request to the server. By default, if it hasn't learned about a DNS server, it will just broadcast out a DNS request to an all 255's UDP 53, the DNS port. You could then use technically the IP forward protocol UDP 53 to forward on these port 53 UDP requests. But generally, just make sure that the AP knows about the DNS server, and that should be all that you need to worry about. This method will work for both a statically IP'd AP as well as a DHCP AP. So let's go ahead and show you how to configure it and then how we can verify that this is actually working on the access point. We'll start off with an iOS-based method. Now with iOS, the only code that actually allows DNS server functionality is router code. You won't be able to do this on a switch, so it needs to be running some revision of 12.4 dot something and newer. So in my rack, I do have a router running, and it's running the appropriate code. So to get this working on a router, if you just need like a real quick and dirty version, or maybe you had a bunch of small sites and you wanted to have a DNS resolution per site, and you had a router on each site, this might be an easy way to do it rather than have to spin up a Linux or Windows server to provide the DNS functionality. So if you wanted to do this in the iOS, you really only need two commands. The first command is to just turn on the DNS server functionality, and that's going to be the IP DNS server command. Okay, now it will actually respond to DNS requests. The second command that you're going to need in there is a host name, so it needs to know how to resolve a specific host name. So we'll put in the host name for Cisco CapWAP controller. That would be IP host, and then we need the name. So in this case, Cisco CapWAP controller, and we'll do proctorlabs.com as our domain name. proctorlabs.com. Oh, and then an IP address to resolve it to. Again, this is going to be the management IP, so I'll do, in this case, wireless LAN controller 2, which is 112.10. So IP host, the DNS name, the IP address to resolve it to. If I want, I could also do that LWAP one, in case I have any APs with older code on them. LWAP. And that's it. Now, I just need to go ahead and make sure that my AP gets an IP address and knows how to reach out to the router as a DNS server. So let's go and we'll configure a DHCP scope for VLAN 113, where I have another access point here that hasn't joined up to a controller yet. So IP DHCP pool VLAN 113. We'll start off with those two same commands that I did before. We'll give it define the network. This is a /24. We'll need a default gateway. Default router in this case. 113.1. And now I need to tell it about the DNS server. So two commands there. DNS server, so the IP address of the DNS server, in this case, my router's IP address. And we should also tell it a domain name, so it adds that suffix to the end of Cisco CapWAP controller. proctorlabs.com. All right. Now if I go to my access point, I'm going to watch the logs. The logs have a very large amount of useful information in terms of trying to debug or troubleshoot these discovery methods. So we'll see it pull an IP address. Right now, we can see it's actually trying to resolve Cisco CapWAP controller. And we see right now it's trying to use the domain server of all 255. So it didn't quite get that DNS server entry. And the reason for that is once I added those first couple lines in of the network and the default router command, it assigned the IP address before I got to the DNS server and domain name part. So what we have to do is we just kind of have to wait for this to cycle through again. But what we want to see is when it tries to translate Cisco CapWAP controller, I want to see the IP address of my DNS server. That's going to tell me, did it actually learn which DNS server to use? And if it was able to resolve successfully, at the very end, it's going to have OK in brackets. So that's what I want to look for. And then here we go. So it resolved Cisco CapWap controller.proctorlabs.com. It used domain server 10.10.205. And it said OK, which means it actually resolved to an IP address. And we see that it actually did join. Now let's say, maybe this stuff has been running for a while, and it's hard to find this log. If you want to just see if it's working, what you can do, not Costco, log in. The default username and password is Cisco with capital C, password is Cisco with capital C. Just ping Cisco-capwap-controller and just hit enter. Here we're verifying, was it able to reach out? Did it reach out to the correct one? And then whatever IP address it resolved to, that's the IP that's learning. So with that, we not only verify, okay, was it able to resolve something, but did it actually resolve the correct IP address? So if it was a bad IP address, we'd discover it right here. So if you see the OK, but it's still not trying to join up to a controller, it might be because it didn't get the right IP address. And in that case, we can validate what IP address it's resolving to just with the simple ping command. And yes, you do have to have reachability between the AP and the controller. So we'll get into that in the next series. The next series, or V-lecture I'm going to do next month, is specifically troubleshooting the join process. So we'll definitely talk about all that stuff in the next V-lecture. But here, I just want to make sure that I'm configuring it right. And I want to verify that it is actually discovering the controller IP address. So here I did discover that. Now, one additional thing you can do with DNS, one of the limitations of DNS is you can only learn one controller IP address at a time. But if you want, you can sort of round robin the IP addresses that an AP would learn by having multiple A records or host entries in your server. So I could configure, two of host records that both resolved Cisco CapWap controller, but to different IPs. And then what would happen was the first request, the server would return IP address 1. The second request, the server would return IP address 2, and back and forth as new requests come in. So while you can't discover multiple controllers at once, you can somewhat load balance them across different controllers using that. All right, so I was using it in iOS. Only works on routers, won't work on a switch. Let's show you doing Windows Server. And I should have logged in earlier. This might take just a minute for me to actually get logged in the first time to my Windows server. So assume the DNS server is on a different subnet. Let me just get this. Okay, request. Assume DNS server is on a different subnet. Can we let the DNS request from the AP reach that via the IP forward? Yep, so if you wanted to not tell the APs specifically what DNS server to use, you wanted to use that IP helper method. So what you would do there is on the switch, let me get to my switch here. You could do the IP forward protocol, UDP, and then the DNS port 53. And then on the SVI configured for your access points, do an IP helper command, specify your DNS server IP address. And in that way, when you look at the logs, you would see it would still show all 255s because it didn't know the specific controller to use. But it would probably still say OK because it was actually able to resolve it. And it would still work fine. But I would more try to teach the AP the DNS server right off the bat. Now, the one time where you might want to do that, if you statically configure an IP address on an access point, say you had a very brand new AP, fresh out of the box, and the only discovery method you could possibly ever use was a DNS. And you had to use a static IP address on the AP. When you configure the static IP address on the AP, that's fine, very easy to do from the CLI of the AP. The only problem is you can't configure the DNS information, the server and the domain name via the CLI. You can only do that in the GUI once an AP is already joined, but if you can't discover the controller to join up to, you're in this chicken and egg scenario. So that might be one case where you could use the IP forward protocol UDP 53 forwarded on, and then that would work. But you can also always use a myriad of other methods too. So that'd be about the only corner case I'd see where I would maybe make that a regular part of my process. Okay, let me close this out here. Well, I guess my server didn't quite get wiped out as much as I want to. Let me see if I can close this real quick. This will be the easy way to close it. Not Explorer, Internet Explorer. Yep. All right, go away. All right, so in a Windows 2003 server, other servers will be very, very similar. But once we have the DHCP DNS service running, we would go into our DNS application. We would look in the forward lookup zone, find the domain that we want to put the entry in. We might have multiple domains, so I have proctorlabs.com here. And then we would just need a new A record, so you could just right-click on it and choose a new host. And again, Cisco CapWap controller, 2 L's. And the IP address 10.10.112.10. We never really have to worry about creating a reverse lookup, so this PTR record, that would be to look up the host name by IP address. Never needed in a discovery process. Maybe you do it just for your own benefit for troubleshooting, but not needed. Oh, and I already have it. So I can see it was already created for me. But if I want to, again, I could create multiple records with different IPs, and then it'll just round robin those responses back. But once you have this, then you just need to make sure that the access point knows to use the Windows server. And again, very similar process. It's just now the Windows server is supplying the DNS resolution. So easy to use, but the restrictions, 1, I can only teach it 1 IP address at a time, and 2, this is global. So if you want to have different controllers advertised in different sites, this is a much less useful tool for that. So it's probably one of the less used methods for controller discovery once you start getting a little bit bigger environment. Very small environment, you only have 1 controller, works just perfect. All right, so that would be the DNS method of discovery. All right, now moving into a discovery method that a lot of us are probably maybe a little bit more familiar with, and that's going to be DHCP. First, we'll start with option 43. So with this, only going to work on access points that are actually using DHCP to pull their IP addresses. This won't work on a statically IP access point. What we need to configure on the DHCP server is this option 43, as well as entries to say, okay, when an access point requests an IP address, I'm going to add in this extra information to tell it management IPs to discover. Now, when you format the option 43, it's in a little bit of a puzzle in terms of how to actually format the string for the option 43. So let's talk about that first, and then I'll actually show you how to configure it both on the iOS as well as on Windows box. So the format is always going to be in hex. So all hex characters, we don't get the benefit of using just dotted decimal notation. And the format of the string is going to always start with F1 plus the number of wireless LAN controller IPs that we're advertising times 4. So if we're advertising one IP, it would be 4. If we're advertising 2 IPs, 8, and so on up the line. And it's always 2 digits. So technically it'd be 04, 08, 0B, because we're in hex. And then finally, the WLC IPs. And again, this is going to be in hex. So let's say that we want to advertise 2 controller IPs. 10.10.111.10, which is our WLAN controller 1, 10.10.112.10, which is wireless LAN controller 2 in our rack. All right, let's go through the steps. So we always start F1. Now I want to advertise 2 wireless LAN controllers, so 2 times 4 is 8, but I need 2 digits, so it's going to be a 08. And then the IP addresses of my controllers in hex. So every dotted decimal number here is going to be represented by 2 hex characters. So hex, 10 decimal to hex is going to be A. So it's 2 characters though always, so 0A for 10. I have another 10, 0A, and I'll go ahead and do the top one first. So 111 in hex is 6F. And the only reason I know this is I've done this a whole ton of times. And then another 0A. So here, that's WLC1. So it's always 8 characters of hex. And then do the next one. So another 10.10, so 0A, 0A, 112 is 70, and 0A. WLC2. So there's our string to advertise these 2 IP addresses. Know how to format this correctly because you will need to use that. All right, so let's show you how to make this work. First, we'll go ahead and do it in iOS. So we'll go on Cat2. In VLAN 114, I haven't configured that yet, so I have 2 APs there. I have a 3500, sorry, a 1260 and a 1240 series AP. So let's go ahead and do that. We'll create a DHCP scope. So IP, DHCP, pool, VLAN 114. Again, we always give it a network and a default gateway. Network 10.10.114.0, it's a /24. Default router 10.10.114.1. And then we need that option 43. So on the switch, it's going to be option 43 in hex, and then the actual hex string. So if I just take that line that I did before, F1, 08, 10.10.111.10, 10.10.112.10, enter. Let's go ahead and take a look at my APs. Now I probably just missed it, kind of the same thing where I had the network statement in there first and then it pulled an IP address and didn't quite get the DHCP. If it worked, we will see it directly after the translating entries. Now you'll notice on this AP, it's kind of a good example, going back to the DNS, this one's actually trying to resolve both. This was an 11, this is a 1240 AP, so it started on older code and worked its way up to newer code. So sometimes you'll see it doing both, but anytime it's newer code, it'll always be the new one. Okay, so we didn't get on that first one. We should see it on this attempt now. So I'm going to wait. And again, it always shows up after the translating Cisco Cap Web controller part. Oh, I already grabbed it. So these are the lines I want. We can see here that DHCP option 43 is working because I have these lines. And then I can also validate how many IPs I learned and which IPs I learned. So here I learned 10.10.111.10 and 10.10.112.10, so the appropriate IPs. If these lines didn't get in there, that means you didn't get option 43 enabled correctly. If you have the wrong IPs, it means you messed up somewhere, translating your decimal to hex, and then you just have to go back to your option 43 config and fix it. So never hesitate to use the calculator to convert decimal to hex. It just makes your life a whole lot easier if you aren't real quick at doing it yourself. So that's the way to validate, to configure it on the iOS, as well as validate that option 43 is working. Just look for these lines. It's always after the translating Cisco Cap Web controller, and then just make sure you have the correct number and the correct IPs, and you're golden. So that's doing it with iOS. Let's show you how to do the config in Windows. So with Windows, if I was going to use Windows as my DHCP server, let me go ahead and pull it up here. So I have my DHCP panel open. So I already have a scope pre-configured. Let's take a look at what options are there right now. So right now I'm giving it a default gateway as well as some DNS. So let me take out the DNS stuff so it doesn't actually accidentally use that. So you'll always want the router option in there. But let's go ahead and configure the option 43. So right click on scope options, configure options, scroll down and find option 43. And then in the binary, just leave those two initial zeros there and then just type in the same hex string that we had before. I'll go ahead and just advertise a single controller in this one, so F104, and I'll just do wireless LAN controller 1. So 0A, 0A, 6F, 0A, so 10, 10, 111, 10. Okay, and there we see it in there. There's the string. So now if I go to my switch, I'll get rid of my DSP pool that I had before. No IP DHCP pool VLAN 114. And then I'll just go to the VLAN 114 config and do an IP helper. So any of those DHCP requests that come in, we'll forward it on to the WCS server, or sorry, my Windows server in this case, 10.10, 2.10.6. One way for me to kind of get these guys out of where they're at, I could do clear capwap AP IP address. So let's get rid of the IP address it has. This takes a second. And I'll also get rid of any default gateway that it learned. So this is going to cause it to close. It's going to have to go ahead and pull a new IP address. And sorry, to get it to actually, all right, here we go. There we go. Now I only learned one, and it's the correct IP address. So configuring it from iOS, configuring it from Windows, that's how you're going to do it. So with option 43, this works for every AP. It doesn't matter what model it is, you know, and actually it works across every non-AP too. Will also get this extra information. They'll just ignore it. But option 43 is included in every single DHCP response. Now maybe I don't want to advertise this information to every client under the sun in the DHCP scope, or maybe I want to advertise a different set of IPs based off of the model number of AP. If I want to do that, that's where I get option 6D. So this is basically conditional option 43. I'm only going to return that option 43 information if something matches. So it looks like I have a question. As I know you need to specify the AP type in the DHCP option 43 server. No, for just plain option 43, you don't actually need to specify the AP type. For option 60, that's where we get into this. So when an AP sends out a DHCP request, it includes a piece of information called a vendor class identifier. Basically it says, okay, this is what I am. So it'll say basically Cisco, AP, and its model number. So the DHCP server can look at that and say, okay, based off of this vendor class identifier, using option 60, I can say, okay, yep, I see that you are a 1240 series AP, so I will give you these wireless LAN controllers to discover. Oh, you over here, you're a 1260, I'll give you a different set of IPs to discover. So we're option 43, it doesn't care what it is, it always returns this option 43 information. Option 60 only responds with those IP addresses if a specific vendor class identifier is matched. So it's based on the vendor class identifier, or VCI. Now there's a document that you can look up. If you just Google Cisco option, AP option 43, you'll get right to the document that lists all of them. But the general format of this vendor class identifier is going to be Cisco with a capital C space, capital AP space, lowercase c, and then the model number. So, 1240 or C3500, just basically take the first 3 digits of the model number, maybe it was a 3502, just make the last digit a 0, and 90% of the time, that's what it is. But always look up the document just to be sure. But again, it's almost always in that format. Oh, thank you for sharing the link there. Okay. So based off of documentation, you can configure this on an iOS device. Based off of experience, the config doesn't work right. So what they're going to tell you in terms of how to configure this, if you can actually find the document, it's not even very easy to find. But what they'll say to configure option 60 on a iOS device would be, say I went to, IP DHCP pool VLAN 113. So this is where I had my option 43 configured additionally. They're going to tell you to say option 60 in ASCII, and then that vendor class identifier string, Cisco AP C1240. And then the second piece of config is the option 43. Option 43, hex, F104, 1010, 11210, whatever it is. So the idea being that if it matches the vendor class identifier, I'll respond with this. Problem being that it doesn't matter if it matches it or not, it just always sends back whatever the option 43 configuration is. So this command up here honestly seems to do nothing. If it's a 1240, it'll return the information. If it's 1260, it'll return it. If it's 3500, doesn't matter. It always returns this. I've tested this both on switches, router code. It all seems to be the same. So unless someone else knows the magic formula that's not in any document I can find and not in any forum that I can find, it's just not going to work in the iOS. So if you need to configure option 60, you're going to be configuring it on Windows or some other non-iOS based DHCP server. So let's actually show you that on a Windows server. So I'll get back in here. So in this VLAN 114, I have 2 APs. I have one that's a 1240 and one that's a 1260. So let's go ahead and have the 1240 learn controller 1 and the 1260 learn controller 2. So let's get rid of my this here. So I don't have just a default option 43 configured. I'll specifically configure option 60. This takes a couple steps, so let's kind of go through those steps. First step is we're going to have to define these vendor class identifiers to match off of. So right-click on the server itself, and we're going to define vendor classes. We'll add. And then the display name, I usually name it after the model of AP that I'm going to be matching. So I'll just call this Cisco 1240 APs. Now we edit the ASCII part of this one. So we're in the ASCII field. And then we type that vendor class identifier. So Cisco space uppercase AP space lowercase c 1240. Repeat this. We'll do it for the 1260 as well. Cisco 1260 APs. Again, Cisco AP C1260. Now I can differentiate between 1240s and 1260s. You would have to do this for every single model of AP you wanted to support if you were doing option 60. Okay, so I have my vendor class identifiers specified out. Second step is going to be to set a predefined option. So we'll right-click on the server again, choose Set Predefined Options, and then we'll go ahead and find our AP. So here's my 1240, and then I'll click Add. Now the name here, this is how we're going to be advertising the controller IPs, so I could just say something like WLCs. The data type is going to be IP address, and it is in an array. And finally, the code is 241. Now the way, sometimes this can be hard to remember, so If you remember the original hex string we did where it started F1, 04, whatever, if you convert F1, which is hex, to decimal, it's 241. So 241 in decimal, F1 in hex, that's kind of a way to remember. If you can remember one, you can get the other. And then we'll do the same thing on the 1260s. Add, let's call it WLCs. You could specifically name the WLCs if you really wanted to, but it's just a descriptor. IP address, array 241. All right, now I've kind of set the stage. I can actually configure this on the server now. So on the server, we're going to add a new option. So right-click on the scope options, configure options, go to advanced, find the vendor class. So we'll do the 1240 first. And we only have one sub-option, 241. And now, at least with this one, I can actually just type in the actual decimal representation of the IP. So I could say, on the 1240, we're doing wireless LAN controller 1, so 10.10.111.10, 111.10. I could keep on adding a whole bunch, so I could do 5 different ones if I really wanted to. But I'll just do one for now. And then I'll do the same thing, except for the 1260s. So advanced, choose the 1260s, check 241, 10.10.112.10. And now I just need to have my APs reach out to my Windows server for DHCP. So let's see if I have that working or not. Where did I leave off? So see if I have a DHCP pool configured. I should have that deleted. Yep, so we're on VLAN 114. I don't have it configured there. And do I have my IP helper still in there? I do. All right, so now if I go to my APs, I should be able to just sort of give them a little kickstart to restart the discovery process by removing their IPs. They'll pull a new IP address and they should get this information. So clear capwap AP IP address. Do the same thing on LAP3. Get into enable mode. Clear capwap AP IP address. All right, so pulled an IP address. So it's going to begin the discovery process again. We should hopefully see that this is the 1240. So this should learn WLC1. The 1260 should learn WLC2. Looks like we're pretty close. It's the one right after translating Cisco CapWap controller. Oh, I goofed this. This is a different one. All right, so this one is a 1240, so it did learn 1. I was wrong about the model number on the LAP3. That is a 1040, actually. So let me fix that. Scope options. Oh, let's create a new one. So define a vendor class, add Cisco 1040 APs, and the ASCII Cisco APC 1040. Go in and define a user predefined option for it. 1040s, add. It's an IP address, array 241. I can get rid of my 1260 entry here and instead put in the 1040. Configure options, advanced. Find my model number here, 1040, and we'll do WLC2, 10.10.1112.10. Add. Give it a kick in the pants here. Clear capwap AP IP address. And then we should see that it learns just the 10.10.112.10 address. So both of these are in the same subnet. They're both in the 114, but they're getting different controller addresses based on their model number. So that's option 60. And again, does not work in iOS, even though it says it's supposed to work. You can actually configure it. But if you do it according to documentation, it flat out doesn't work. Doesn't matter if it's on a switch, router, possibly in maybe the iOS XE, they fixed it there. I don't know. I don't have one of those devices handy. But again, I'm always validating option 43 in the logs of the APs, just looking for after it does the Cisco CapWAP controller resolution. Right after that, look for the option 43 entries. Do I have the correct ones, correct number of them? And that's option 60. So my normal recommendation would just be, if you don't care about advertising different controllers based off of different model numbers, normally I would just say just use option 43. Because the classic case I would see clients run into, so when I worked at a Cisco partner before I worked here, so dealt with a lot of different clients. Usually what would happen was, okay, we'd go in there, we configure up their network for them, and for some reason, did option 60, great. Then all of a sudden they start ordering a new model number of APs, and then it wouldn't work because they don't have a vendor class identifier matching for it. And they would call us and we'd have to troubleshoot it. If you do just option 43, you never have to worry about it because regardless of the new model number, it continues to work. The downside of option 43 though is it does return that information across all devices. So even if you have non-APs in there, it's still going to be advertising option 43 to it. So it's extra information. They'll just discard it. So normally it's not a problem. Looks like I didn't disassociate from my controller. So let me clear it again, see if I can disassociate before I actually get my new IP address. Otherwise, I'd have to just go ahead and reboot it. That usually does fine. We'll just let this reload and we'll come back to it. But that would be option 60 here. You only need it if you need to advertise different IPs based off of AP model number. Most people don't. But the common configuration you see in Cisco documents show you just using option 60, so everyone kind of thinks that they need it. You don't. You can do plain Jane option 43, and it works just fine on a Windows device. Okay, so these are really the three main dynamic ways of discovering controllers. Let's show you more of a static way of discovering controllers. And that's going to be with just a static primary, secondary, tertiary config. So on the APs in the CLI, you can always go in. And let me go ahead and clear out the different discovery method we had configured for this. So this one should have been DNS. So I'll go ahead and remove the DNS information from the DHCP pool. So I'll just delete it and recreate it. No IP DHCP pool VLAN 113. Put it back in with just a network statement and default router. All right. So on my access point, if I just get into the console of it, so usually you would use this method if you're just gonna, stage an AP and then, put it out in the field. So to configure it, you would do, there's actually two methods. So it's going to be CapWAP. Sorry. CapWAP AP controller IP address. So this is kind of, I think, the older way of doing it. You can only configure a primary controller through this. So this is just going to configure a primary controller by address, and you would just say the address that you want to reach out to, 1010, 112, 20 in this case, WLC4 for us. Now this is always going to be remembered on reboot. So even if I reload this, it's going to remember this forever until I totally clear this out. So that's one way to do it. That's kind of the quick and dirty way of doing it. But if you want to do it a little bit more formally, it's going to be CapWAP AP and these primary base, secondary base, and tertiary base. So primary base, we need both the controller name and the IP. So I could say WLC4, if I can spell it right, and then the IP 10.10.112.20. We can configure a secondary base, WLC2, 10.10.112.10, and even a tertiary, WLC1, 10.10.111.10. So you won't ever really see logs about its discovery attempts for these, but you can verify it pretty easily. Once you're in the CLI here, show capwap client config. Shows you lots of good information. It's going to be towards the top, and it's all these MWAR entries. So the first one is the primary, second one secondary, third one tertiary. So if you ever want to validate that these configs actually did make it onto the AP itself, that's how you do it. Show capwap client config. It will automatically, once it gets to the discovery process phase, reach out to all of the controllers on this list as potential controllers to join up to. So a very simple config, very simple verification that at least it is configured. And if, we'll save the rest of it for the troubleshooting the join process. So pretty much automatic discovery, not relying on any dynamic method. If you can't control, DHCP server or DNS entries, oftentimes if we do like an Office Extend deployment where we set up an AP for someone to plug in their home router and join back up to our controller in the DMZ or whatever it's going to be, this is almost always how we have to do it because we can't do option 483, we can't do DNS, so we're just priming the AP to reach out to the appropriate controllers. Or if you want to always have a controller prefer to join, an AP prefer to join a controller over another, this is also when you're using that configuration. So do this anytime you can't use a dynamic method, or if you really want to control on a per AP basis what things are being discovered. Which takes precedence? Primary base, they both actually configure the same entry. So right now I have, the last thing I did was primary base. And if I do a show capwap client config, I see right now my primary base is WLC4 to 10.10.112.20. I haven't tried this, but what should happen is if I do the capwap AP controller IP address command, it should overwrite this entry, I believe, is what's going to happen. But let's try it. Capwap AP capwap AP controller IP address, and I'll just do something random, all twos. Show capwap client config. Yep. So this is the specific entry that the capwap AP controller IP address configures. The capwap AP primary base, secondary base, tertiary base configures both the name and the IP address. So same spot for both commands. But good question. All right. Now we have one final method of discovering controller IPs, and that's with remembering both the controller that the AP was previously joined to, as well as other controllers in the same mobility group, specifically with the same mobility group name as the controller it was last joined to. So right now, WLC1 and WLC2 are configured to be in the same mobility group. So let's flip over to a GUI, a little easier to see that. Okay, so WLC1, probably have to relog in here. No. We can see that it is in mobility domain HQ. WLC2 should be in the same. So they're the same name, and then if we go to the mobility group list, they are in each other's mobility group list, although didn't quite get up, but honestly that doesn't matter for this, this conversation. As long as they're in the list, on this list here, with the same group name, the AP will remember all of those controllers. So if right now I'm on WLC1, I'll remember WLC1 because I was on that one, as well as any other controllers on the list with the same group name as WLC1. So if I look at my APs, and actually let's see, which access points do I have joined to some of these All right, so on WLC1, I have, looks like WLC2 or LEP2 and LEP3 based on their model numbers. I know this. To verify this, go to the AP itself, show CapWAP client config again. And if we scroll down a little further, we'll see these entries, configured switch 1, configured switch 2, and so on down the line. These are the IP addresses that's learned based off of, one, who am I associated to, and then who else is on that controller's mobility group list with the same name. So right now, this access point knows both WLC1 and WLC2. Now it's going to remember these if I reboot it. So if I pretty much unconfigure all other discovery methods here, let's go ahead and do that. Right now these guys are on VLAN 114. Which I believe is still being served by the WCS. So if I go to my Windows server, which is my WCS server in our lab, apologize for using the same name. Let's just get rid of these options. So it's just going to give it an IP address with a default router. And for kicks, I'll even delete the DNS entry. So there really is no dynamic way for this to learn about the controllers. Go to my AP. So I know it's learned them because it's joined up to them. But let's go ahead and reboot it. Reload. We'll have to suffer through the reload process here. But once we get up, it has no other way of learning, because we didn't have, if we scroll up, we didn't have any primary, secondary, tertiaries configured. Let's see, do I have the UDP broadcast forwarding, show run, include forward, enough forwarding layer 3 broadcasts across any subnets. DNS resolution is not working. It's not even learning about a DNS server anyways. Option 43 is not configured. Option 60 is not configured. So it has no other way of dynamically learning any controller IP addresses. But since it was previously joined to a controller, it will always try to, it remembers that, as well as any other controllers in the mobility group list with the same name. If it's a different name, it doesn't remember it. So usually where you run into this is, maybe you're trying to get your AP to join up to a specific controller, but it was previously joined to something else, and it keeps going back. And the reason for that is it is remembering where it was last joined up to. All right, so we're almost there. So if you ever need to get rid of any of this information, whether stop it from remembering what it was previously joined up to, or forget about what it had maybe hard-coded as a primary, secondary, tertiary, whatever it is, you can enter or which one was I on? Yeah. So right now this one has the hard-coded ones that it remembered. Now, before I do that, all right, so it has an IP address. Before I let it join, show CapWAP, oh, come on. Show CapWAP client config. So it hasn't joined up yet, but I still remember those two switches. So not only the controller it was on, but others in the same mobility group name as long as they're in that list. Okay, and now it joined up. So that's the last method there. But if you ever want to forget that or forget your hard-coded primary, secondary, tertiary entries, clear CapWAP private config. Show CapWAP client config now. It's gone, it doesn't have any. So normally what you would do is you'd say clear CapWAP private config, reload it, and then it's going to come up pretty much brand new, fresh. It'll be using the code it was currently booting, but all the configuration's gone. So usually if you have this AP continually connecting to a controller that you don't want it to because of one of these methods, it has it hard-coded or it remembered from previous joins, clear CapWAP private config gets rid of it, reboot, and it'll come up brand new. So that's pretty much it. those are the 5 methods. So just kind of reiterate, go back to our beginning here. Layer 3 broadcast, use the IP helper trick because most of the time our APs aren't on the same subnet as our controllers. Usually this is just a quick and dirty way to get it up on a controller. You don't want to leave it in that state with all these layer 3 broadcasts. But it works for both static and dynamically IP APs, and we can advertise multiple controllers. DNS works for both static and DHCP APs. We can only advertise one controller at a time, although we can do multiple controllers in a round-robin fashion. Option 43 works across all APs that use DHCP, regardless of model number. Option 60, DHCP only, but on a per vendor class identifier basis, so per model number. Hard coding primary, secondary, tertiary, this works on everything, and it's remembered across reboots. So even if some of these DNS or DHCP stuff stopped working, this is always working as long as it's configured. And finally, previously known, once it's joined to a controller, it remembers the controller as well as any other mobility group members in the same name. So, CAPWAP discovery method. Any questions? Let's see. What about order in case we don't have a master controllers in order for AP to join? No, at that point, if it doesn't have a primary, secondary, tertiary configured and we don't have a master controller configured, the tiebreaker on that one is the least loaded controller. So based off of, I'll show this real quick. I think after my join troubleshooting, the next one is going to be high availability, which we'll get into topics like that. But least loaded, and it's based off of a percentage. So how many APs joined divided by total licenses. So whatever the smallest percent of that wins. So if I have a 500 AP license controller and it's got 100 APs on it, it's 20% loaded. If it discovers my DMZ controller that has 0 APs on it and only 12 licenses, it's 0% loaded. Sorry, 0. He's the winner because 0 is less than 20, even though this guy has 400 licenses available. This guy only has 12. It's a percentage base. All right, did I miss any other questions in here? Okay. How many controllers to remember? So it's only AP controllers with the same mobility group name. The theoretical limit for that is 24. So it might be 20, might be 24, but boy, I sure hope you don't have that many controllers in the same mobility group name. Might be time to look at breaking that up a little bit. All right. Any questions about anything, I guess, that we talked about here today? At least more specifically the CAPWAP discovery process here. The next time we'll do, the next V lecture is going to be about specifically the join process. So how does the join process work? How many ways can it go wrong, and how can we troubleshoot that? So that's kind of the next step. Once we've discovered the controllers, now we need to join them. How do we make sure that that part goes smoothly, and what do we do when it doesn't go to plan? And I think the next one I'll do after that hasn't been advertised yet, but I think I'll do a high availability. So how do we do join preferences, failover priorities, advertise, the order that we should be failing over and things like that. Okay, well, it doesn't look like we have questions. I guess we'll call it done then. If you ever need to get a hold of me, jrensink at ipexpert.com. Always feel free to reach out to me if you have questions about certs or whatever. As much as I can, I'll respond to your questions. Otherwise, we have an online study list for all the different levels of certs. Great place to just be able to bounce questions off of other people that either have the cert or are studying for the cert. You should see this video, I believe, both on ipexpert.com as well as in our YouTube channel. We've got other videos in our YouTube channel, so you can always check those out for other free resources as well. But other than that, again, thank you guys for showing up, and hopefully we'll see some of you guys on a regular basis as we start doing these more and more often. So everybody have a good day, and we'll hopefully see you soon.